Now loft boss base add material, while loft cut will simply remove the material. So let's first explore loft boss base. Loft feature create a 3D shape by blending between two or more profile. This is the clear cut difference between sweep and loft. In sweep, we have only one profile which follow the path. Here we are going to connect two or more profile of different shape or same shape. So loft can be base, boss, cut or surface. Here if you look at the example, this is like a soft drink bottle cap where there is a, on the top there is a circular profile and at the bottom there is another profile. So it is blending between them. If you look at this fire extinguisher nozzle, there is a slot shape like over here at this end, and at this end we have a circle. So this plastic part is a classic example of loft feature. So loft is useful to create shape like a bottle, mouse body, car body, airfoil, turbine blades, funnel and nozzle, where there is a transition between two different profile. So when you start the loft, the property manager offer a lot of settings. The first part is you have to choose the profile. You can order the profile selection. Then we have to learn what is start and end constraint, how the guide curves affect the overall shape of loft feature, and then we'll discuss the centerline parameters. Now open the exercise 8.12. Now here I have created two sketch. One is circle and second is rectangle. Now I want to create a transition between these two profile. I can only have to use this loft base, though I can use this boundary boss base, but for such scenario loft boss base is better. So click the loft boss base. Here I need to select the profile. Now select the circle. Now remember, when you select the profile, try to select the point on a sketch which is similar to the next profile. For example, I am selecting the circle over here. Same way I am going to select the second profile over here. Now the purpose is we want to connect these two different profile at a same locations. Now here let's go ahead and click OK and to see what is the outcome. So here circle is merging with the square profile. Now square profile has 4 corners, but the circle do not have 4 corners. So loft feature arbitrarily divide the circle geometry into 4 segments and try to connect with the second profile. Now let's edit again. This green dot is called connector. If I click and drag it, it will simply twist the profile outcome. So let me twist further and click OK. So we need to understand the effect of connector. So let's go ahead and try to edit it. Now if you see only one connector and if you want to see the default all connector, now why we have a 4 connector here? Because from these two profile, square has maximum 4 corners. So that's why arbitrarily SolidWorks offer 4 dot, that is connector. If it is not visible, right click and select the show all connector. With the help of this connector, you can control the shape of loft. So try to organize this point in this way. So if you require, just orient yourself and try to connect or place the connector in a similar way. So you can have a better control over surface. Click OK. So this way, by simply connecting two profile, you can create the loft feature. Now let's discuss how the start and end constraint affect the outcome of loft feature. So go ahead and open 8.13 exercise. Now click on loft boss base and select the profile. As mentioned earlier, try to choose the point similar to each profile. Now because these two profiles are perpendicular to each other compared to the previous exercise, SolidWorks through Loft will try to connect the two profiles straight. But what we want to control how the material will flow. So with the help of this option called start and end constraint, we can do that. So the start constraint, let's say at this moment we have none. Moment I choose to normal to profile, see the effect over here. So the material which is flowing out at these locations. Now if you want same thing at the another end, then go ahead and select for the end constraint to normal to profile. Now here you will see the purple arrow that shows direction and magnitude. If you increase the magnitude, let's say 1.5, look at the changes. It pushes the material upward. Let's apply same on another section. So by controlling this kind of direction of start and end profile, with the help of start constraint, you can control the overall shape of simply loft features. Let's go ahead and click OK. So this way you can apply the start and end constraint. Now let's edit it again. Now here, instead of the normal to profile option, let's choose direction to vector options. So here let's choose proper plane, and for this I will choose the top plane. So the selected vector remain perpendicular to our default plane, right plane and top plane. So this way you can also define the movement of material through vector. It is not necessarily the plane. You can also have some guide construction geometry which will provide the directions. But with the help of such constraint, you can control the outcome of loft feature. Now let's explore further options available in start and end constraint. For that, open the 8.13 exercise, which is second exercise for the end constraint. Now here, start the loft. This time I will choose this top surface and this point. Now at this moment, if you compare with the earlier exercises, we had sketch. Now in this case we have a cylinder and we are using its top face as a one profile, and we have a second profile as a sketch. Now we want to control how the loft gives the outcome. For that, as mentioned earlier, we need to control the start and end constraint. Here, because we have a cylindrical surface, few more options are also available other than the direction to vector and normal to profile. I will choose tangents into face. So here, this circular surface is used as a reference. That means the flow of material remain tangent to the previous circular surface or cylindrical surface, you can say. Same way, for other side, you can choose normal to profile because it is a sketch, and for the sketch we have only two options. So this way you can control the flow of material. Now let's right click and show all connector. Here I will try to manage the flow of material by moving the connectors. Make sure while moving it, you do not force the part material to shrink or crumble somewhere. If it is happening like that, it is going to fail the entire loft features. So let's go ahead and click OK. Before we continue to explore other options like curvature, let's understand the difference between tangent to face and curvature. Let's say I have a curve like this. So if I add the another line in this direction, I can say there is a tangency relationship. But for the same thing, if I draw again, if I continue this curvature in this direction, then I would say it is called curvature continuous. So this is the difference between these two options which are available in loft under the start and end constraint when we have a cylindrical end faces, which will give the very subtle control over how the material or profile will connect to each other. So this will help us to create a very organic consumer product. Now open the exercise 8.13.1. Now here I have two solid bodies created by a sweep feature and loft. Now what I want to do, I want to connect this profile with this profile. For that, I have to start the loft feature. Now I will choose this surface and this surface. Moment I do that, SolidWorks offer me connectors. Okay, so let's try to move to proper location so you can have a preview. Moment the preview disappear, that means it is not possible for the loft feature to create the material. Now here let's explore the other option called tangency to face and normal to curvature to face. Now let's choose first part is tangency to face. So at this location I am making the flow of material tangent to previous selected surface. Now for the end I am doing the same thing. Now let's click OK. Let's go to evolute and try to see the curvature. Here you will see that curvature is, let's say, value 22. So very immediately it changes, right? So this curvature tangency relationship is maintained only at this location, and then gradually the profile is merging with the opposite end. Now let's go to start the zebra strips. Now here look at very carefully when I change the options. So edit the loft we have created. This time let's change from tangent to face to curvature to face. Just look at the zebra strips. See, they are getting wider. Again tangency to face, again curvature to face. On opposite side same thing, let's switch to curvature to face. So as explained in slides, that curvature to face will give more organic outcome. Now you can also control the value of magnitude of this tangency or curvature. So let's enter the value 1.2. On opposite side let's enter 1.2. So with the help of such constraint you can control the flow of material as per your requirement. Let's turn off the shape. So look at the outcome. So by changing the magnitude you can also control the value. Now in this exercise we'll explore how to use guide curves. But basically we need to understand what it does. It simply controls how the outside surface flows. So here guide curves are additional curves that control how the loft transition between two profile happens. So you can say guide curves add precision and smoothness. So in this exercise we are going to connect this profile with this profile. First we'll try to see without guide curves and then we'll add the guide curves. Now let's try the effect of guide curves. So click on loft boss base, select this profile, select this profile. Now let's select the guide curves. Because guide curves are drawn in a single sketch, we need to select by using the selection manager. So here I have to select from the group. Select this, right click. So one guide curve is added. Similarly, select second one and right click. So because of guide curves, we are able to control the flow of material outside. Now I deliberately kept this zebra step on. That is through option called curvature display, zebra steps over here, right? So the purpose is you can see this top surface is having uniform thickness of bands, light and dark. That indicate it is having uniformity in surface. So let's click OK. Now let's study the effect of guide curves or influence of guide curves on overall surface. For that, open the exercise 8.15, start the loft features, and let's say these are two profiles. We want to create a loft between them. Now I have two guide curves. So I will choose this and select this one guide curves. Right click. The moment I do that, the guide curves influence type is turned on. Here I have 4 options. Let's discuss one by one. If I kept global, that means the effect of this one guide curve will be observed on entire surface. This is our entire surface. So global means it is simply affecting the entire surfaces. So moment I switch to other options called next to guide. For that I need to select one more guide curves. So let's select this guide curves. So this next to guide curve simply do one thing. So from here this guide curve gives its effect till the half sections, and these curves simply continue its effect to the half sections. So when we have two guide curves and we choose the next two guide options, they simply divide the zone and affect halfly to next sharp. Now what it does, it try to affect the surface, but moment it find a sharp edge, it stop over there. So effect of guide curves or influence will simply stop at the sharp corners or sharp edge of a profile. So this is our profile, and this is the corner, and this is going to create a sharp edge. Same thing happen over here. This guide curve influence will stop over here because of corner. Now let's see and click OK. Now to explore further the influence of guide curves, open the part 1. Now in this we have two rectangle as a profile and 3 guide curves which are color coded. So let's try to create a loft. Now I will choose this corner and this corner, opposite corner. So SolidWorks can able to create a proper loft. Here I haven't added any guide curves. Now let's try to see how it affects. So moment I select this guide curve selection box and add over here, and here I will choose the next to sharp, what happened? Only that surface is going to affect, not the rest of surface. How can I say? Let's click OK and go to the volute and click on this one, curvature. It display the variation of curvature on the surface. Now see, all the other surfaces are black in color, means they are having same curvature value. But because this top surface is having one guide curves and it is only affecting to that surface. So this happens because of option called next to sharp. Now let's change next to guide. What will happen? It continue the effect of curvature, that is effect of these guide curves for all surfaces. It pushes the all other outer surfaces, right? Now let's add one more guide curves over here. So moment I do that, it simply pushes the other surfaces. Now let's add one more over here. Now because I have selected all the guide curves, and let's try to explore one by one further. When I choose the global, see there is a change in the zebra strips from edge to this and to global. So there is a variations effect. So here all these three guide curves are uniformly controlling the outer surface of the loft feature. Now let's go to the first option called next to guide again. So these guide curves will continue its effect till it's meet the next guide curves. Over here it's the same thing. So these guide curves will simply affect the zone up to the half, and these guide curves continue to create the influence up to half. Now Loft also offer Centerline parameter. Centerline parameter in Loft lets you define a single path that the Loft follows internally. So you can say centerline is equal to movement of path, while the guide curves are equal to the surface rate. So guide curves control outer surface, and the centerline control the flow of a material equally from the center. So centerline control where the loft will travel, not how the outside looks. So outside look is controlled by the guide curves. Let's try to explore this option. Now open the exercise 8.16. Here we have a 3 profile. So let's connect with loft boss base. Please mind well where you select the profile. Now simply selecting the profile will give us this kind of outcome. Now what we want material to follow in these directions. That means it should remain in center of this curve, which will work as a center line. So let's edit that part, and let's go to the Centerline parameter. This time in selection box I am going to choose this part. So moment I did, try to see how the internal sections are centrally located. So it controls the movement of materials from inside. It does not control how the outer surface looks. So with the help of Centerline, you can guide the entire sections to follow uniformly. So these are useful for creating tabs and similar shape. Now let's further explore the effect of Centerline along with the guide curves. For that, open the exercise 8.16. Now let's choose this profile and this profile. Now let's add a center line, and for that activate this part and select this one. So this is the outcome. Pay very close attention to these zebra stripes. Now here let's click OK to see the effect. Now let's add it again. This time I will remove the center line part, and I will simply add the guide curves. So as we understand that guide curves is simply control the outer flow of a material. So look at the zebra stripes. It is little bit changed. Now start the zebra strip from evolution tab, and this time we'll try to explore the effect of the combination of these guide curves and center line. Now let's remove the guide curves. See the change in the zebra stripes. Now turn on in evolute tab the zebra stripes. Now let's edit the loft. This time I have chosen only center line. Instead, I will remove that part and I will try to add the guide curves and click OK. See, looks like a similar to the center line, but the thickness of stripes changes. So it's a minute difference, but it affects the overall shape. Now let's add it again. This time I will club the effect of these guide curves with the center line. So select the center line. The moment I did, see how the strips are varying. So there is a minute change in the zebra strips thickness, but it is important. Now similar to loft boss base, loft cut simply remove the material. Now rest of the options are same. Philosophy of guide curve, center line are remain same. So here in this exercise we try to create a cut like this using the provided profile and guide curves. Open the exercise 8.17. Now instead of boss base, let's try loft cut. Now select the profile. Make sure you select at appropriate point on each profile so that the connector are in line. If they are not there, try to move them. Now here, you are having difficulty in setting the connector. So right click and show all connector. This way you can control the placement of connector and overall profile. Now let's choose guide curves. I will add this one, right click, and this guide curve and right click. So this guide curve simply control the movement of material between the selected profile. Click OK. So this way you can simply create a lofted cut feature. It is very useful to create a internal nozzle shape. Now let's build this model using loft feature. Here in this exercise, as given, this is one profile, second profile, third profile, and fourth profile, and this is fifth profile. So we are going to create loft between these 1, 2, 3 and 4th, and then we have a second loft feature between this profile to this profile, and we'll give the appropriate dimensions. Start new part file. Make sure the unit is in millimeter. Now on a right plane, I will create first profile. So use the circle. Now diameter is 85. Now exit. So select the right plane, press Ctrl and then drag from here. It will create a parallel plane, but at distance. This time I have to give 40. Click OK. Again create a new sketch on this newly created plane. So the second circle is having 80 millimeter diameter. So click on it and add the value. Again, let's try to create another plane which is at 65 from the right plane. So select the right plane, press Ctrl and drag it and add the value 65. Now on this plane, plane number 2, create new sketch which has got circle of 50 millimeter. Now again exit. Now let's add the fourth profile, which is a rectangle having 65 by 60. Now it is located from 90 millimeter from the right plane. So select it again and drag it. So overall distance is 90. Now again, select the new sketch options, choose the midpoint rectangle options and add the dimension 60 and 65. Now exit. Press Ctrl 7 to see all of these profile. Now let's turn off the display of all these planes. Now let's create a loft. Please mind where to select them. So over here, over here, over here and over here. So selecting that sequence, otherwise your profile will get twisted. Once you get the desired results, click OK. Now from this surface, we need to create one more plane. So click on plane, select this surface and keep the distance of 210. Now on this plane, create a new sketch and having rectangle profile whose dimension is 5 and total is 150 as given in sketch. Now also we need to create a connecting cow or guide cows. For that I have to choose front plane and select the cow. This time I will choose 3 point over here, over here and over here. Now let's give the radius which is 220. Now select this top surface, press Ctrl, select this and make sure PS relation is applied. It is mandatory. A guide cow must connect to the profile. Similarly, here we already have this coincident relationship. Now let's exit. Click on loft base, select this surface and this end. Now see it's completely skewed. So let's move this connector over here. Now activate the guide cow selection box and select this part and right click. Let's turn off the display of a plane. So we have a hammer head. Here we need to connect this circle with this slot sketch to create the nozzle of fire extinguisher using loft feature. So start new part file. Now this time on right plane, I am going to create a circle of 30 diameter and I will exit. Now from this right plane, I am going to create one more plane at 300 millimeter distance. On this I will open new sketch. This time I will use center straight slot. Now let's add dimensions. This is 60 and radius is 15 and exit. Now let's turn on the display of a plane. Now let's connect these two profile using the loft. Select the profile over here and exit at same point. Now see, the most of the time the SolidWorks will try to manage the location of connector. But in case if you have a difficulty, then right click and click on show all connector and try to manage the location of this connector to control the outer shape of a feature. So in this case, I think it is okay. Now let's go ahead and click OK. How can I say it is okay? Just go ahead to Evolve tab and click on Curvature. So the overall pattern is uniform. If I divide from the middle, the right and left sections are uniform, even top and bottom. So you can say the connectors are properly connected to each other from these two profiles. Now let's apply the cell features. This time the thickness will be 1 and I will keep this part open, this two end open. Click OK. So this way you can create the nozzle of fire extinguishers. Now in 8.22 exercise, we are going to create a flywheel. Here we have two features, circular ring and cylindrical part. Now I have drawn two ellipses at two ends and they are connected through a center line. So let's create one part and then mirror it using the loft feature. Open the exercise 8.22. Now let's start the loft boss base. Try to see how the ellipses are drawn. So pick this point and similarly this point. Okay. So I will use Centerline parameter and will force the section to distribute itself from the center line uniformly and click OK. So one of the rib of flywheel is prepared. Now let's add fillet. So choose the edges and click OK. Now here choose this loft and select the fillet and go ahead and select the circular pattern. Now we have to choose only the reference surface, that is circular part, because we already pre-selected the feature. So here we have to add the 5 ribs. So this way you can use the loft feature to create the flywheel. You can add further, just select these things. You can add the cutout over here. So select and make sure it is having enough dimension, let's say 60. Now let's add from here, it is vertical. From this to this to this. Okay. Now select this, control press center line and select this and make it symmetric. Now we add some value over here. And this should be, let's say 5 mm. And this should be again, let's say 5. Let's make the square slot. Now let's extrude and cut it. This part and this part. And make sure it is through all both. So you can complete the flywheel.